In this quiz, you need to have the Pythagorean identity memorized. And the first one that we've talked about, and really the only one we've talked about this unit, is sine squared theta plus cosine squared theta is equal to 1. Now, that's really the one that you have to have memorized. And where the other two forms of that equation come from are just taking the original equation and isolating different terms. So, for example, if I want to get sine squared by itself, I'm going to subtract cosine squared from both sides, which will leave you with sine squared theta is equal to 1 minus cosine squared theta. And we can do that one more time. Again, going back to the original function, if I want to get cosine squared by itself, I'm going to subtract sine squared from both sides. So that will leave you with cosine squared theta is equal to 1 minus sine squared theta. And we're primarily going to use this unit for just direct substitution. And typically it happens with one of these two forms. So typically what happens in these kinds of problems is you're going to see something that has a sine squared in it. And if it's a sine squared, and if you can't factor out how it's written, you're going to replace it with 1 minus cosine squared. And likewise, if you have a cosine squared in your equation, you could replace it with 1 minus sine squared if necessary. So let's go ahead and take a look at number 1 on the online homework. It's not online homework, it's your quiz review. For this one, we don't have to do any factoring because there's just one trig ratio involved. So what we need to do is we need to isolate that one trig ratio, or in other words, just get it by itself. So we have to start by adding 1 to both sides. So 3 cotangent squared theta is equal to positive 1. Divide both sides by 3. So left with cotangent squared theta is equal to 1/3. At this point, we can go ahead and square root both sides. Now be careful on this one, because when you square root a fraction, what's really happening is you square root the numerator and you square root the denominator. So this will be equal to 1 over the square root of 3. And then to rationalize the denominator, and to turn this cotangent value into something that we recognize, we're going to multiply both the top and bottom by radical 3 over radical 3, which will give us square root of 3 over 3. So what we're looking for are the angles where cotangent of theta is equal to positive or negative radical 3 over 3. Now the reason why we have to put the positive or negative is because we were the ones that introduced the square root into the equation, and when throughout the process, if you ever end up having to take the square root of both sides, it is not known whether or not your answer was the positive or negative of that square root, so we have to put the plus or minus. So to solve this, you might find it easier to think about, instead of where does cotangent equal positive or negative radical 3, chances are you probably have a better grasp with your tangent values. So whenever cotangent is equal to radical 3 over 3, that's where tangent would have equaled the square root of 3. And again, where we're getting that number from is just taking this and taking its reciprocal. So you reverse the numerator and denominator, and after you rationalize the denominator and simplify it, you end up with just the square root of 3. Now tangent is going to be equal to the square root of 3 at all of the over 3 angles. So we have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, if the directions just said solve from 0 to 2 pi, we'd be done, because that lists out all of the angles on the unit circle where cotangent is radical 3 over 3. However, the directions here say give a general formula for all solutions, and that's where you're either going to be putting on a plus pi k or a plus 2 pi k to give every possible solution that your angle could be. So you might find it helpful to label your quadrants. And the thing about these angles are, let's see here, pi over 3 is here, 2 pi over 3 is here, 4 pi over 3, and 5 pi over 3. So what you'll see happen is pi over 3 is exactly pi away from the 4 pi over 3, or the angle that's in the third quadrant. So because those angles are just pi away from one another, we can write the general formula by just saying pi over 3 plus pi k. Because again, if I add pi, like you see here, to pi over 3, it will give me the other angle. So there's no reason for me to have to rewrite the 4 pi over 3, because this formula takes care of it. Similar thing's going to happen with the 2 pi over 3. 2 pi over 3 is right here. 5 pi over 3 is right here. As you can see, these angles are exactly pi away from one another, or 180 degrees. So we only need to use the smaller of those two angles and add pi k to it. Because again, if I add pi to 2 pi over 3, it will give me 5 pi over 3. So the general formula for all possible solutions is just going to be pi over 3 plus pi k and 2 pi over 3 plus pi k.